So this topic is simplifying expressions of the form, and then we've got the nth root of x to the n. So this is coming from section 3.1. This is like the first objective in 3.1. It's the basics to understanding how to simplify radicals, which is really important knowing how to do when we're solving quadratic equations. It's really important if you are going into electronics, because you do end up dealing with radicals there. So it's a good skill. It pops up in various places. So I'm going to just start with various definitions and all, such various things. I think this is actually, now that I'm looking at this, I don't think it's section 1.3 now, because we recently changed it. I think it's like section R or something, but so I'll just erase that. But basically just a review of the square root symbol, because we're going to be extending the square root to other roots. So the rule about something being a square root is that b is a square root of a if when you square b, you get a. So it's basically undoing squaring something. It's saying if you're taking the square root, you're saying what squared equals this number I'm taking the square root of. So the general symbol, we often call it the square root symbol, but it's actually called the radical sign because it's used for more than just square roots. But in general, just some examples here. If 3 squared equals 9, then the square root of 3 will give, or the square root of 9 gives you 3. Now the square root of 9 also gives you -3 because -3 squared also gives you 9. So square roots generally have two answers, a positive and a negative answer. And we call a positive one the principal square root because that's the one that we use most often. And if you're not being told to solve, we generally assume we're going to want the principal square root or the positive one. But if you are asked to solve, which is something that you will be doing, you'll be solving equations involving radicals, then you actually want both of them. And so we use plus, this is a plus or minus symbol. It's a plus on top of a minus sign. And that tells us that you want both the positive and the negative answer. Now, one thing to note is if you put these in your calculator, you're only going to get the positive. So you have to know when to also add the negative because the calculator will not give you both. So that's something to know. You can't just rely on a calculator here. So the whole thing that we're going to be doing is simplifying these, and we're going to just start with simplifying square roots, and then we'll go into, cubed roots and kind of generalize that. But the basic rule is like if you've been doing with square roots, which most people have dealt with so far, as you only have dealt with square roots, they often don't come out to whole numbers. And so if you put it on your calculator, you're going to get a decimal. And usually we kind of round to 2 decimal places, but we don't really like to round. We want to keep it in its radical form because that's exact. And so when we say we're simplifying square roots, we're trying to make the inside part as small as possible. And if it's possible to take things on the inside and bring them outside of the radical symbol, then we do. So, and then just a general, if it's a word problem involving these things, we usually will use the decimal form, but we usually round to 1 or 2 decimal places. So just a note there. So this is kind of setting up with what we're going to be doing. We're going to be doing more complicated things. We're going to be doing them with cubed roots, and we're going to be doing these with variables as well. But I wanted to start out with the context of a square root because that's what people are most familiar with. So what we're going to be talking about is the nth root. And so when I read the title out loud here, the nth root, that's how you read that symbol. When you read this thing to the end, that's read as the nth root. And n is just the number of roots. So square root would be a 2 because it's reversing squaring. That's why it's called square roots. We could have 3, we could have 4, we could have 5, And those are all completely valid. It's just saying now we're undoing a different exponent. We're no longer undoing a 2 for the exponent or square. We may be undoing a 3, a 4, a 5, and so on. So the square root is basically the same as this nth root symbol. We just, if there's no number there, we always assume it's the square root. Otherwise, we put a number there to specify if it's a different type of root. So that number, the n that's written there, is called the index. And then the thing that's underneath the radical symbol is called the radicand. So that's just some vocabulary there that you're going to know. But what we're doing is we're basically trying to undo exponents here. Yeah, you have a question? I heard the raise hand thing, but okay, if there's no questions, if that was an accident, we can move on. I just wanted to stop because I heard that. Okay, so nth roots, this is what we're going to be focusing on here. So as I said, the normal radical symbol without a 2 means a square root, and you can also see it with the 2. Those both mean the same thing. So we can have different values for n. So if you see it with a 3, we call that the cubed root because you're undoing cubing. So the cubed root of 8 gives you 2 because 2 to the third power, 2 cubed, gives you 8. And the cubed root of -8 will give you -2 because -2 to the third power gives you -8. So that cubed root, you're undoing exponents of 3. You're basically saying, okay, if we wrote like this answer is 2 to the third, it basically cancels out that exponent. You're left with what's underneath the exponent. And we have other roots like 4, 5, you know, we can keep going. So I don't know why this is highlighted. It won't let me delete it. Okay. So when we have things with exponents, and this is going to be the basic rule that we're going to be doing when we're going to be simplifying things, is we're going to be dealing with things that have exponents because the whole point of taking a root, square root, cubed root, or whatever, is to cancel out the exponent. So that's our goal. And there are 2 ways we write our answer depending on if that index, the number that's, you know, kind of above your radical symbol, is odd or even. So if it's odd, then the symbols just cancel out and you're left with whatever number is underneath. So a good example here. So let's say I want to take the cubed root of -64. So this is actually -64 is what you get when you cube -4. So the radical, the cubed root cancels out that 3 in the exponent. And so our answer is -4, basically what's under that exponent. So that's what this odd says. And so if we had something different, like if it was, you know, let's say 5 to the third, it just cancels out that exponent. You're left with 5. Now, if it's even, if that index is even, it's slightly different because of the fact that anything that has an even exponent, you're never going to get a negative out of it. And so that's why the rule here has these absolute values, because you can't get a negative from an even root based off of the rule, because an even, like a square root, you're undoing something that is squared. And so if you had a negative in there, a negative times a negative is a positive. So it's never going to give you a negative answer out. So an example of what this is saying is, let's say we wanted to take the square root of -4 squared. Our answer here is not -4. So we just can't, with an even, you just can't cancel out the exponents and get -4. It's actually the absolute value of -4. So your answer here is 4. And this is a special rule for even roots. And the reason for that is because if we had an answer of -4, we would say -4 to what power, you know, gives me -4 squared, which was 16. Or you would say, sorry, what to, wait, let me try to figure out how to explain this. Yeah, I'm trying to figure out a good way to explain this, because this is really difficult for people, and even I'm having a hard time to figure out a good way to explain this. I'm gonna have to look into a better way to explain that, because I can't think of anything right now. But just know that this is the rule. Just know, you know, that it's, when we take this, we're going to say that our answer is a +4 versus a negative in this particular situation. That we're not just going to cancel out those squares. You're going to have the absolute value of whatever's underneath there, and then that's going to give you that positive out. So just take this as this is the rule. It is very confusing. I'll see if I can find like a video explaining this or something like that. When we do things with variables, we always assume the positive so we don't have to deal with the absolute value thing. And in practice, most of the time, you don't have to deal with this absolute value thing at all. So this is just some key differences that we generally, whenever you take like a square root of something with even integer, you don't really get negatives out. You're going to get positives out, but you can have negatives out when it's an odd. That's the basic rule, what you want to know here. So when we move with variables, what happens is you're basically dividing the exponent on the variable by whatever your index is, or your root. So a square root would have an index of 2, so you divide your exponent by 2, and that will allow you to undo that that square root thing. Basically, when you take the square root, you're dividing the exponent by 2. If it's a cubed root, you're dividing the exponent by 3. So the reason why this happens is, let's say I have this, I'll take the x to the 4th. So using our rules of exponents, we can rewrite this as x squared squared, because our rules of exponents say that if you have a square on top of a square, you multiply those exponents. So 2 times 2 gives you 4. So you can see that, oh, okay, now my square root cancels out my outside square, so I'm left with the inside, which is x squared. And so the same thing with that cubed root, or the 6th, we can rewrite this as x cubed squared. So 3 times 2 gives you 6. This is the same thing. This the square root cancels out the square, and you're left with what's underneath the square, which is x cubed. And so when you have like a cubed root, if we have that same cubed root with x to the 6th, we'd want to cancel out the cubed. So it's like basically equal to the same thing, x cubed squared, but we just rearranged the order of the exponents. And then it cancels out the 3 on the exponent, and we're left with x squared. So Erica's question is, why would we want to rewrite it? So generally, this middle step where I'm rewriting it, you don't do that. I'm just showing you why it works, why this is the rule. But normally you wouldn't have to rewrite it, although some people like to rewrite it so they understand what's going on. But if you don't want to do that, if you don't want to rewrite it so you see what's really canceling out, then you just basically use the rule or the fact that you're dividing it. Does that make sense? Okay. And if it doesn't divide it, then you can't take the root. So like if I wanted to take the root of x cubed, I can't divide that out. 3 divided by 2 gives me a fraction or a decimal. So if you're not getting a whole number, then you can't do that. There are ways around this that we will do by rewriting it, kind of splitting it up differently. But in general, you can't just divide it and say, okay, now the exponent's going to be 1.5, because we don't want exponents that are really decimals or fractions. So we would like leave it like this unless you tried to use one of our other tricks, but I'm not covering that trick right now. You know, I just want to focus on the basics because this stuff does get really confusing for people. So the best way to really understand all of these rules and what's going on is just to see it in action. That's really, I mean, we've got all these things, I've got it written down, but seeing it in action is what will really make it make sense. Really, you'll see what's going on. So if it says simplify the radical expression, your goal is to, if you can, get rid of the radical or the symbol altogether. Sometimes you can't, but if you can, you want to do that because it just that's what it means when we say simplify here. So our goal is to remove the radical if possible. And as you get further on in section 3.1, you'll see there are situations where you can't get rid of it. But I'm just focusing on the ones that you can so you understand how to get rid of it. So that way, when you move on to the next section, you understand why some things are left over. So, you know, we're starting just from the very beginning because this is a very, very kind of, you know, it's hard to get all the rules into place. It will take some practice. So I'm going to just start on the top line here. I've got 2 examples. One's with an odd index. So it's 5 is an odd number, and then one is with an even. So this is going to be using that rule. Let me go back here. The odd versus even thing, where we're going to have to worry about the square or the absolute value with the even. So this is just going back to here, the difference between an odd and the even when you have that as your index. So if it's an odd, so we've got our 5th root of -8 to the 5th power. Those completely cancel out. When it's an odd, you do not have to take a square root, or you don't have to do absolute value. They just completely cancel out and you're left with -8. Now on the right, we've got even. So the square root is canceling out a square. And when it's an even, your answer is not -8. You have to take the absolute value. So we're going to have the absolute value of -8, which is actually going to give us a +8 for our answer. So this is the difference here, is if it's an odd, you can get a negative. If it's an even, we want the positive out. And I think I just figured out a way to explain that. I was trying to explain that earlier and I couldn't quite figure it out. So let's say we've got this -8 squared. If I square -8, that gives me a +64. So I mentioned that basically there are 2, you know, you can get 2 answers from here because you could have -8 squared to give you 64, or you can have 8 squared giving you 64. There's 2 possibilities here. And so let me go back to the slide where I mentioned that right here. So we have this sentence here. If we are not solving, we assume the positive square root, because you could get a positive or a negative there. So if I go back here, our answer could be either -8 or +8. So we're assuming the positive, which would be 8. And so by taking the absolute value, when you see it written this way, that corresponds with that rule that we want the positive version out. Does that make sense? Does that help that? Because I was really struggling before, and then it just came to me. So I don't know if I confused you further, but hopefully that kind of makes sense as why we're doing the absolute value there. If it doesn't, just follow the rule. Sometimes there's things in math where you just need to follow the rule. Okay. So that's the top. That's demonstrating the difference between odd and even. And those rules are specifically when there's numbers. So we've got the examples, we've got the numbers. Now it's different with the variables, because you don't have to worry about the absolute value thing. So the second row here, I've got I've got an even and an odd again, so you can see kind of the differences here. So on the left, we've got the 4th root of y to the 4. So it's an even exponent, but it doesn't matter when it's a variable. It's just they just cancel out. So your answer here, the 4th root cancels out the 4, and your answer is just y. Now on the right here, I've got the cubed root of y. So y doesn't have an exponent of 3. These cannot cancel out, because on a y, this is equivalent to an exponent of 1. Like if there's no exponent, it's the same thing as having an exponent of 1. And so you have to be able to divide it, and it's the inside divided by the outside in order for this to work, not outside divided by inside. So the inside is 1, the outside is 3, it'd be 1 divided by 3. But that gives you a fraction. So we cannot simplify this. And so our answer is literally exactly the same. It's already in simplified form. So if the inside exponent is smaller than the index, and the index is the root, the number for the root, it's already simplified. So there's nothing really to do there. So just a little general rule there, because I get questions where people are like, well, how do I know when I'm done? And so that's that, if it was y squared, that would be another thing. It's 2 is smaller than 3. We can't simplify that. Now, if it's 4, we can. And again, I mentioned that's a rule that we're not going to get to in this session, but there is a way to do it. But if it's smaller than, it's already simplified. So any questions so far?
No, I'm good.
Okay. So I've only got 4 more examples, just to kind of give you a wide flavor, because this is the real meat of what we're doing is the next part where we start doing much more complicated. It's the next objective in 3.1, but this is giving you like the basics. So top left here, I've got the square root, and then I've got in parentheses 3z plus 2. So that still cancels out. Even though we've got this plus thing, we're caring about, we've got something in parentheses squared. So that gets canceled out by the square root. And so we're left with 3z plus 2. And this is something that you'll see when we're solving. So you'll see this again. when solving radical equations, where you will basically be, or not radical equation, solving quadratic, or, because it will have something squared, we call it a quadratic equation, and we'll take the square root to undo it. So that will show up again. So it doesn't matter if you've got something added inside the parentheses, it still completely cancels out. Now on the right here, I've got the fourth root of c to the 32. So the inside's bigger, and we basically just do 32 divided by 4. So 32, if you really want to write what you're doing, not 2. Actually, your exponent is looking like this, 32 divided by 4, writing it as a fraction. But usually we don't write that, or, I was writing it before where I was rewriting, the thing so that it's an exponent of 4. You don't really have to do that. You just do the division. So 32 divided by 4 gives you 8. So your answer here, we simplify. When you do this, the radical symbol disappears. We're left with c to the 8. Now, the ones on the bottom here, they have multiple variables. And so technically, the trick is, and this is a rule that I haven't explicitly said yet, but you'll see it in the next objective or whatever. But if you have something that is like a square root or any kind of root, an nth root with a fraction, you can split those up into 2 separate things. And then you can simplify them separately. And it's the same thing if you have things that are multiplied, where you can split them up into separate things multiplied. Now, I don't normally write that step. I will just remember that, it just happens to everything that's inside here. And I'll go straight to the answer. But that's generally what the rule is. You can split it up, so you can split the fraction up so the symbol's on the top and the bottom, or if you got things multiplied, you can make it each thing multiplied. So with our square root of p to the 6th, q to the 4th, so the square root means you're dividing by 2. So if it helps, you can always write your 2 there to divide it. And so you're just dividing all of your exponents by 2. 6 divided by 2 is 3. So we get p cubed. And then 4 divided by 2 is 2. So then you get q squared. And so it's still a fraction, but you're just, to remove that square root, you're dividing your exponents by 2. Then on the right, so these are things that are multiplied, and I don't usually separate them out. I just divide my exponents. So we've got the cubed root. So that means we're going to be dividing them by 3. So m has an exponent 9. 9 divided by 3 is 3. So we get m to the 3rd. And they stay multiplied. Then 12 divided by 3 is 4. So you get n to the 4th. So they're still multiplied together, but you've basically just made the exponent smaller, and now it's not in that radical symbol anymore. So this is the really, really basic stuff of simplifying radicals. And I wish I had thought to open up the textbook to kind of show you where we're going from here, because it's really important to understand this so that the next part makes more sense. I should have the book open shortly so I can just kind of show where we're at, so you know kind of where you're going from here. Okay, so I have the book in a different format just because teachers have access to different ways to get books. So this is what we're doing. We just did this, you know, everything is simplifying and you're getting, you know, you're not really getting your radical left. We're moving from here to the second objective, and this is where people really get stuck. So understanding this part is really important. And so this is one of the things that I was kind of talking about, where if it doesn't divide, let's see if I can zoom in here. Okay. Oh, no, it moved me. There we go. Okay, so you're going to be taking things that with a higher exponent there, and then we're going to be splitting it up so that you can simplify part of it, but you won't be able to simplify all of it, and you'll have things that are left over. So that's where we're moving from here. So being able to understand this part is important so that you kind of understand how we end up with leftovers, you know, from there. So that's where we're going. And so you're going to be doing this with variables. So you're going to be kind of having some things inside, some things outside. You're going to be doing it, let me see if I can find one with numbers. So you'll be doing it with numbers. So this is, Erica had the question earlier, why would we rewrite something in its exponent form? And with variables, we don't. But with numbers, you do, so that you know how to simplify and rewrite things. So this is where we're going, and this is where people are kind of getting confused. So understanding why we want to rewrite things and the cancellation of exponents is really important so that you can understand what's going on with this thing, because this is what you're going to be doing when you're using the quadratic formula. So just wanted to kind of show you, and then this, you know, is going into when you put it in your calculator, you're going to get a decimal. So, you know, and then we're going to be doing things with numbers and variables. So it does get more complicated, but understanding why things cancel out and how, you know, we're dividing the exponents, that's important. So that's where we're heading. Actually, I'm going to see, I think I have a video going into this. I'm going to double check. Yes. Okay. So I'm going to pull over. Okay. So I have several videos kind of going into the next steps from here. So I've got this one, which just kind of shows it with numbers. This one also is focusing on numbers only, showing how it gets simplified. This one's throwing in variables. So these three videos are going to be very helpful for what comes next from what I just did. And so you can choose, you can just do this one. I think this one covers both. And then this one is just numbers, and this one's things with variables. And so these are kind of splitting it up. And then this one is just all of them at once. So where you go from here, you know, is based off of, do you think you could watch one video and get both of them, or do you think you're going to need it separately in two different videos? But that's where we're moving on from here. And then from there, there's going to be things where you're going to be multiplying these things, you're going to be dividing them, and then that's this one right here. So are there any questions?